All right, today we're going to take a look under the hood of Azure Synapse Analytics. I want you to think of it like this incredible high-performance engine for your data. But, with any powerful machine, you've got to know how to work the controls, right? It's the only way to get the most out of it without completely breaking the bank. So here's the big question, really. In any data warehouse, how do you find that perfect sweet spot between performance, concurrency, and cost? You want lightning-fast queries, right? That's performance. You need tons of users hitting the system all at once? Well, that's concurrency. And of course, you don't want your cloud bill to give you a heart attack. That's cost. The thing is, these three are always in a tug of war. But the good news is, Synapse gives you the levers to manage it. Okay, so let's start with the most fundamental control you have: raw power. Think of it as the master power switch for your entire data warehouse. It's all about deciding just how big of an engine you actually need to get the job done. So how do we measure this power? Well, in the Synapse world, we talk about something called Compute Data Warehouse Units, or cDWUs for short. Now, a cDW isn't just one thing like CPU speed. It's actually a blended measure, a mix of CPU, memory, and I/O, all wrapped up into one simple, scalable number. It is by far the easiest way to just dial the overall horsepower of your system up or down. So what's the starting point? You can begin at just 100 cDWUs. Now, what does that get you? It gets you one compute node with about 60 gigs of memory. It's kind of like the entry-level model, perfect for when you're just getting started or for smaller dev environments. But what about the other end of the spectrum? Well, you can crank that dial all the way up to 30,000 cDWUs. And let me tell you, that's not just a small jump. It's a massive leap to 300 compute nodes. It's a perfect example of just how elastic the cloud is. You can literally go from a small single node setup to a beast of a data warehouse with just the move of a slider. Pretty amazing. All right, so you've picked your power level, you've set your cDWUs. Now what? The next big question is, how do you divide up that power? You've got multiple users, different processes, all hitting the warehouse at the same time. You've got to have a way to manage how everything is shared, right? So let's take a look at how Synapse does that. And yep, you guessed it, this brings us to another classic trade-off. Think of your total power as a pie. Do you give a massive slice of that pie to just one or two really complex queries so they finish super fast? Or do you cut up that pie into lots of smaller slices so many more users can get their work done at the same time? That right there, that's the fundamental tension between performance for one query versus concurrency for the whole system. The way Synapse handles this is with something called resource classes, and you've got two main flavors to choose from. First, you have static resource classes. These give a query a fixed percentage of the system's resources, no matter how much you've scaled up or down. These are great when your workload is predictable and you pretty much know what's coming. Then you have dynamic classes. These are, more flexible. The amount of resources a query gets actually changes as you adjust your cDWUs, perfect for when things are a little less predictable. So here's the bottom line. The choice you make here has a huge impact on your users. If you put someone in a larger resource class, yeah, their big, heavy query gets a ton of memory and CPU, which is great for them. But it means fewer other queries can run at the same time. On the flip side, put them in a smaller class, and the system can handle way more concurrent queries, but each one just gets a smaller piece of that resource pie. Okay, we've hit performance, we've hit concurrency. Let's talk about that third piece of the puzzle, the one that often keeps people up at night: cost. It's great to have this powerful engine, but what happens when it's just sitting there, idling? You wouldn't want to pay for gas on a sports car that's just parked in the garage, right? And this is where one of the most brilliant things about modern data warehouses like Synapse comes into play. See, in the old days, compute and storage were basically glued together, but now they're completely separate. And what that means is you can literally just turn off the engine, the expensive compute part that you pay for by the hour, and all your data stays perfectly safe in storage, which is, by comparison, super cheap. Let's just walk through a really practical example. Think about a normal workday. At 9 a.m., you can have the system automatically fire up the compute resources. Your team does their thing all day, running reports, loading data. Then, at 5 p.m., poof, you automatically pause it. So all night and all weekend, you're not paying for that expensive compute power at all. Just this one simple habit of pausing and resuming can save you an absolute ton of money. All right, so we've covered the big picture stuff: total power, how to slice it up, and how to save money. Now let's zoom in a little bit. Let's get granular. What happens when the system is flat out busy and you've got a bunch of queries all waiting to run? Who gets a cut in line? Out of the box, Synapse is pretty fair. It uses a simple first-in, first-out queue. We call it FIFO. The first query to show up is the first one to get processed once a slot opens up. Simple, predictable. But let's be honest, is fair always what your business needs? I want you to picture this. An analyst kicks off this huge, long-running query to crunch some numbers. It's going to take a while. 5 minutes later, your CEO needs to pull a quick report for a board meeting that's starting in 10 minutes. With that default first-in, first-out system, the CEO's super important, time-sensitive query is stuck in line behind the analyst's monster job. Yeah, that's not going to fly. And this is where our fourth and final lever comes into play. It's called workload importance. Basically, this is a feature that lets you say, hey, queries from this user or this type of query are more important than others. It's like giving them a VIP pass for your data warehouse, an express lane to the front of the line. Now, giving a query high importance does way more than just let it skip the queue. It gives you 3 really powerful benefits. First, yes, the CEO's query jumps right ahead of the analyst's. That's a given. But second, it also helps with locking. So if both queries need to access the same table, the high importance one gets the lock first. And third, and this is really cool, it actually sends a signal to the query optimizer to start freeing up resources, getting everything ready for this critical job to run. So let's bring it all together. You really have 4 main levers of control to master your Synapse data warehouse. Lever 1, scale your overall power with cDWUs. Lever 2, manage concurrency, how that power gets divided with resource classes. Lever 3, control your costs with that super simple pause and resume feature. And lever 4, set your priorities and decide who goes first with workload importance. When you get a handle on these 4 controls, you're well on your way to running a data warehouse that's not just powerful, but also efficient and cost-effective. So I'll leave you with this question. When you think about your own workload, your own users, which of these 4 levers is going to have the biggest impact for you? That's it for this one. If you found this helpful, do me a favor and hit that like button, share it with someone, and subscribe for more. Thanks for tuning in.